for these problems, the problem type is finding the future values and interest for an investment earning compound interest. So the idea is that we're going to put some money and we're going to invest it, and it's going to grow every time period. So in all of these problems, there are the same basic elements as the previous one. There's an initial amount, there's a rate, there's a time period, and then there's one additional thing, and that is how often it is compounded. So let me write the formula down here initially. Our final amount is equal to the initial amount times 1 plus, and our previous formula was always r and then raised to the t power, because after every year it would grow by this percent. However, sometimes this is going to get compounded. We're going to take some sort of percentage of it and add that onto the amount. We're going to do that maybe 4 times a year, or maybe 12 times a year, so either quarterly or monthly. So what we're going to do is we're going to divide that r by n, which is the number of times we compound it, and we're going to multiply that times t, because if we do this 4 times a year, then it's going to be 4 times the number of years. Let's just label our variables here. So this is the final amount. This A is the initial amount. Let's put A and T. R is the interest rate. T is the number of years. And then N, which shows up in both of those places, is how often it is compounded per year. So we'll say number of times compounded per year. So if we're compounded annually, that means once per year, n would equal 1. That's an arrow. If we're compounded quarterly, that's 4 times a year. So n would equal 4. If it's compounded monthly, you guessed it, n would equal 12. Sometimes things are compounded semi-annually, never really daily or anything. Those are pretty much the normal time periods. So let's go ahead and read through this particular problem. Raphael received a $1,900 bonus. That's his initial amount. He decided to invest it in a 3-year certificate of deposit. So our time frame, I can already tell you, is going to be 3 years, with an annual interest rate of 1.37% compounded annually. So annually means n is equal to 1. 1.37%, if we turn that into decimal, so we divide it by 100, that would be 0.0137. Answer the questions, don't round any intermediate complications, write a final answer to the nearest cent. If necessary, refer to the list of financial formulas. Well, this is really the only financial formula that you need. We're going to see, assuming no withdrawals are made, how much money is in Raphael's account after 3 years. So we're going to see how much it's worth. And then the secondary question, how much interest was earned. All right, and that's basically, we're going to take that final amount and subtract the initial amount, and whatever the difference is, then that's how much it's grown. So that's interest equals the final amount minus the initial amount. It's a much more simple formula. All right, so let's go ahead and plug this in. We have final amount equals A, initial amount, so 1,900, times 1 plus a rate, 0.0137, divided by n. Our n value is 1, so that's really pretty basic. And then t value, our number of years, is 3 times n, so 3 times 1. All right, let's go ahead and plug that into Desmos. So we've got 1,900 times 1 plus 0.0137. Now I do the divide by 1 just because I want to keep Desmos the same, I guess. time raised to the power of 3 times 1. I mean, 3 times 1 is going to be the same, but I could put 3 times 1 up there in the parentheses. So 1979.1647, so we're going to round to the nearest cents. That's going to be a 1/6. So we're saying our final amount is equal to 1979.16. And then, if we're in, so that would be the answer to this part right here. If we want to figure out how much interest was earned on the account, well, the interest is equal to the final amount, so 1979.16 minus A, the initial amount, so which was 1900. And this part I can actually just do in my head. I can see the difference between 1979.16 and 1900. It's just going to be 79.16. All right. All right. Very similar type of problem. Carlos receives a $1,100 bonus. That's going to be his initial amount A. He decides to invest it in a 5-year certificate deposit. So 5 years is going to be our T value. It's going to be 5 years with an annual interest rate of 1.44% compounded quarterly. So here our R value is 0.0144. Compounded quarterly means that our N value is equal to 4. That's literally all the bits of information that we need. We would again just put the formula. Final amount is equal to the initial amount times 1 plus the rate 0.0144 divided by N, which is 4, and then to the power of T times N. T, which is 5, N here, which is 4. That's it. You just plug it into the formula. And now we'll slide over to Desmos and put that in. So we've got 1100 times 1 plus 0.0144 divided by 4. Raise it to the power. And I'm going to put a parentheses right here so that both of these numbers are in there. 5 times 4, I could just put the 20 here. But $1,181.968. Now, I'm rounding to the nearest hundredth. So I've got the 6, so I'm either going to keep it or bump it up. I look at the one right next to it, it's an 8, so I'm going to bump this up to a 7. So 1181.97. If I want to figure out what the interest is, then that's going to be that final amount, 1181.97 minus the initial amount, 1100. That's the A value. Simple subtraction, and that's going to be the answer to part 2. So plug in the formula right there for part A. So do the subtraction of the initial, the A minus the F. You think about that's the final amount minus the initial amount, and that's going to end up being your interest. All right. Let's look at one more problem here. It says the bank offers an investment account with an annual interest rate of 1.22% compounded monthly. I say monthly, I say, going right there, N is equal to 12. 1.22%, so that means R is going to equal 0.0122. I think that's saying my invests $3,400, so that's the initial amount. A, for 2 years, that's our T value. Literally just the same formula. Final amount equals initial amount, 3,400, 1 plus the rate, 0.0122 divided by N, 12, raised to the power of 2 times 12. Once you just plug that in Desmos, come up with the number, and then that is going to be our final amount. And so that's this part here, how much money is in the account, and then how much interest is earned. You would just take that final amount that you get and subtract the initial amount, which is 3,400 in order to get the interest. That's how much it grew. Good luck.